Here with the December Sidewinder puzzle from the Snakes collection from Cracking the Cryptip. Now I get to play Let's Get Cracking. For starters, these two 10 cages, the snake can't visit those cages because I need both cells to add up to 10. So those are not snake. And the snake goes from one circle to another, so both of those are snake. Next, the snake cannot visit both cells of this 8 cage because we need because then the sum would be 0. So let's draw a wall. The snake can't cross this wall, and it can't cross these walls, and it can't cross this wall. In this 4-cell cage, I need 3 of these cells to add up to 23, so the snake can't visit 2 of those cells, so it can't cross any of these walls. So up in this area here, we have a cul-de-sac. You know, the snake cannot come in here and go out. It would be touching itself. It can't go up here and come back. It would be touching itself. So we've got a little cul-de-sac here. So let's go ahead and fill that in with not snake. And then we have a cul-de-sac here and here as well. The 2 walls and the other non-snake squares form a cul-de-sac, so the snake can't go through there. Next, we want to ask whether or not this is a snake cell or not. Let's start by assuming it's not a snake cell. Well, that makes this a cul-de-sac, so it's not a snake cell. But now we've got this 4-cell area which needs to add up to 9, and 4 cells have to add up to at least 10. If we try and stick, this needs to be a 1-2 pair to add up to 3. This needs to be either 1-5 or 2-4, but since there's a 1-2 pair here, it can't be 1-2, and 4-5 don't add up to 6. So this has to be a snake square. Now, can the snake square, what's adjacent to the snake square? Can the snake square come over here? Well, if the snake square comes over here, these are both non-snake squares because I need 2 squares to make 12, to add up to 12. But once I do that, I have a cul-de-sac again. And as, we fill this in as a cul-de-sac, well, I'm again got a 2x2 cul-de-sac here. And now we have a contradiction. I need these, the snake can't be in here, and I was assuming the snake was in there. So the snake, that can't be a snake square. That has to be a non-snake square. Okay, so the snake has to come through here. It has to have 2 neighbors on this side, and it's going to have to come around through here. It's going to have to come out through one of these squares. I need one of these squares to be a non-snake square so I can get at a sum of 12, and the snake has to come out. Okay, let's go and fill in some of the values that we've discovered. So, and ask where this 6 goes over in box 3. Well, it can't go in row 1 because we already have 6 in row 1. It can't go in the 12 square cell because we'd end up with 2 6s to add up to 12, and that won't work. So we've got to have a 6 up here in row 3. The snake's going to have to come out through this 8-cell cage in one of these, so we're going to have the other cell is going to be non-snake, and it's going to have to be an 8 to make the sum work. In this area here, suppose the snake comes through one of these 2 bottom cells, and it doesn't really matter which one we look at. Let's just pick one of these and look at it for a second. Suppose the snake comes through here. Well, that means, so in our 3-cell cage, we need 6, 8, 9 to add up to 23. But we already have a 6 and an 8 in that row. So that means we end up needing a 9 in 2 different places that see each other. So that's not going to work. So that's, these 2 bottom cells both have to be not snake. Once we do that, the snake has to come through this region here to get from this side of the board to this side of the board. And that forces this square to be a 3 and non-snake to make the cage sum work. Now I've got 3's looking at all the squares in this cage. So, you know, if we tried to put a 3 in there, it would tell us that that won't work. So we've got to have a 1-2 pair in there. And the snake comes this way. We don't have enough room, so the snake's going to have to come this way. And this is going to have to be non-snake, and that's going to be our 1-2 pair. The snake's going to have to come out through this square, and that's going to force this square to be a non-snake 8. If we look down here at this 8 cage, well, it doesn't have an 8 in it, and doesn't have a 1 in it, and that's going to be a problem. Let's start by, you know, what if there were 3 snake cells in here? Well, that adds up to 0. That contributes 0 to the sum, and we can't solve the cage sum. So suppose there were 2 green cells in here, and it doesn't really matter which ones we pick, but let's suppose, you know, so that's going to leave us with 1 cell that needs to be an 8, but it can't be an 8 because we already have an 8 in that row. Well, maybe there's 1 snake in this group, and again, it doesn't really matter which one we pick. You know, what's going to happen is we're going to end up with, you know, this is part of a cul-de-sac. This is part of a cul-de-sac. That makes this a cul-de-sac. That makes this a cul-de-sac. And those all have to be non-snake. Contradiction. So that means we have 0 snake cells in here. But in order to form an 8 with 3 cells, we have to have a 1 in here. We can't use 2, 3, 4, you know, and we can't even use the 3. 2, 4, 5 adds up to 11, not 8. So we can't put anything down here in this 8 cage region, and so we've shown that the puzzle is broken. Obviously the puzzle's not broken. Somehow, you know, my logic must be wrong. People solve this. It's a solvable puzzle, but I can't figure out why my logic is wrong, and I'd appreciate any help anyone can give me.